All right, it's Ken Delcor here. Let's take a look at the last section on the 131M310A limits and fan controls module. So this particular page has already got a few little notes specific. Now, up until now, we've talked about the high limit, talked about the fan controls, and now we're primarily going to hit up on the remaining of the limits that would typically go on in here. So of a typical unit, whether it's a rooftop, a boiler, a forced air furnace, whatever that might be. So we'll hit up on the remaining sections on this. So first thing that I'd like to hit up on is if we start looking at, the first one I want to deal with is essentially going to be called the flame rollout limit switch. Now, what is the primary function of a flame rollout? And so when we look at the operational, the function, the purpose, what do we want it to do? So I think to some extent, when I think about the primary function, when I think about the primary function, so primary function of, or primary function, primary intent, maybe I'll put on there, primary intent is to stop the gas train should a problem occur. Should a problem occur. That's really the primary, and specifically should a problem occur with, let's say, the heat exchanger. With the heat exchanger, or with, actually I'm going to say this, with a heat exchanger, let's call it blockage. Either blockage or, let's see, blockage slash opening, slash restriction, these are all things that can cause that one to trip, which is a pretty major one. That's one when you start seeing rollout limit failures or opening up. The first thing that most people start thinking of is some sort of a lack of air, lack of air or a blockage in heat exchanger. Those are typically what. That's typically what I would refer to it as. That's kind of the norm on there. Now let's look specifically at the location. So the location of this control, we'll say, whoops, select. Okay. So that location on there, they're generally always located around the entrance to the burners is typically where they are. So that's normally the way I would probably look at those. And I would say, when it trips, I would say either due to, it could be either due to reflective heat, that's one way. Could be due to the reflective heat off the heat exchanger, or it's searching for air. So it's pretty major of when I say that, it's pretty significant. If you start seeing a rollout opening up or that's kind of a little bit of a problem. So you got to be looking at do we have a problem with the heat exchanger? Is it plugged up? Is it what's going on with this thing? So Is that I've seen even boilers where just due to the amount of soot on the bottom of the heat exchanger was enough to cause enough heat to be reflected back and cause it to open up. So it's something that you look close at a number of things. So a lot of times with these, it's really a process of elimination. When I have a rollout that goes out, I need to eliminate things. I need to figure out, you know, unless it's totally obvious, but I need to take a look at some things. All right, so moving on. So as far as the application, so the first thing that I would say is this is a major deal. So I would say expect it to be a manual reset or fusible link. All right, it's, whoops, fusible, not disable. So fusible link. Expect it to be something like that. Obviously, if it's a fusible link, if it is indeed a fusible link, let me back up a step. The fusible link is, it's once and done. That's the problem with the fusible link. That little picture to the right is one of those examples. If it is a, if it's a bimetal, if it is indeed a bimetal, they will normally be manual reset. Whoops. They will normally be manual reset. So what you're looking for, there we go. They will normally be manual reset. So essentially, this one here, this is a fusible link. There's no button, so there's a little link in there in between those two that's kind of hidden in there. That will melt and it doesn't allow any current to go through. If it is a manual reset, you're going to probably see a little button. So typically, I would venture to say that a majority of the time, that little button here will be some sort of like a red button that, you know, it's going to be whatever it might be, but you'll see it. It's pretty obvious. So where you're going to always see these located is certainly going to be in, you're certainly going to run into that with somewhere around the entrance to the burners. And so I'm just kind of showing that here in a couple of spots here. So one of them is my rollout. That's listed down in the bottom here, that rollout. And the rollout limit, you'll notice, is right in a burner box. Now, if for some reason you don't have a burner box and it's the whole chassis of the furnace ends up being the box or the burner box, there's going to be a limit around the burners. It's going to be around the wiring to protect the wiring from getting all burned up. So that's kind of the one area that I would look at. So let's talk a little bit about how does that work. So I've talked a little bit about its function and its application and what goes on here. But let's talk a little bit more in detail on that. So on a typical, let's take a typical condensing furnace as an example, or even a rooftop would apply to this as well. So on a typical unit here, we're going to allow some of our gas to flow. So in other words, our burners are going to typically be going, you know, the flame is and the heat is leaving that burner, and you're expecting the inducer motor to be pulling those products through the heat exchanger if at all possible. So they're actually going in this manner as the direction is showing here, and it'll go out the exhaust blower and straight on out. All right, now that's what we're expecting. Now what happens now in these systems is when we have any situation where, let's say, there becomes an excess of restriction. So let me back up one step. The one thing that in addition to not only do we pull the products out, but that's also it pulls the products in. So for example, this arrow that's shown on the fresh air intake pipe, that is an indicator. That's what's basically saying, hey, if we're pulling air out, we have to pull air in. And if anything that goes on that would prevent let's say, prevent any of those products of combustion from not leaving, for whatever that is, whether it's an opening in the heat exchanger or a blockage or restriction, anything that would do that, there is only one device that would actually prevent this unit from going off, and that is indeed the rollout limit. Now the rollout limit, you might say, well, how in the world would that do that? A pressure switch will not, and it will never. The pressure switches typically will not solve this problem or will not pick this up. So what you got to realize is that if there's any issue, a blockage in here, a blockage in the secondary, or an opening in a heat exchanger like this, what will happen is you're still going to be putting the gas into the furnace, and you're still going to be putting it into the burners. However, what will happen now is it's going to say, hold it, what happened to the air? If it can't pull them through there, if that isn't happening, this isn't happening. So in other words, you're going to literally have an issue where you're going to have a problem with it it's not going to feed enough air into the fire. And once it does that flame will start looking for it. Now, typically, it doesn't happen that abruptly. Normally, this is something that progresses gradually, and you'll notice it because it's really gonna hit it up. And all of a sudden, you'll notice the flames will start to waver a little bit. Now, in my Blackboard folder, I have a video in there that will show what it looks like or what it could look like on some systems. Now, obviously, every system can be slightly different, but that's one of the big things that we kind of look at. The other, but that's kind of the one thing. So obviously, we got an issue there. It is the only thing that will, as a general rule, will protect you is this rollout, this manual rollout limit from some sort of an internal blockage in a heat exchanger, as a rule. But there are appliances nowadays that actually can detect a blockage via the pressure switches, but a majority of them do not. So let's take a look further at this. So typical, as far as the wiring in that, the first thing I would address here on the wiring side is that I would say that it's normally wired just prior to the ignition module. Typically, that's how you see them wired. So they're going to be wired just prior to the ignition module, so that in the event that it's a pretty serious problem. If you got a manual reset limit, that's a major problem. So if that one goes out, you got to start looking, all right, what in the world is going on here, and really do some verification. That's kind of the one thing I would definitely identify on there. So this one here, again, once and done, you may not see it melt. In fact, most of the time, I would say these fusible links, when they go out, I would say a majority of them, it's what they call a meltable link, and it's typically not visible. It's almost like a fuse, where you're not going to see it. You're not going to see. What you won't see is you're not going to see this link or this fusible link just kind of open up. You'll measure it. You'll know it based on the voltage, or based on the voltage drop or the resistance. But it's basically, think of it like a fuse. That if you blow a fuse, it's an open fuse, but you can't really tell that it's open fuse unless there's a visual indicator. So that's kind of the big thing on there. So let's get into the next the next area. Let's talk some troubleshooting in there. And what do you do if you find one of these have, one of these has tripped? So I would say the first thing is to use caution. This is a serious problem on there. So to use caution, when you're going to reset. So when resetting the limit on this one. So I use it, when you're resetting that limit. So, and obviously here's the kicker, if you're there watching it, when you fire that unit back up, so when you try to fire that unit back up, the flame, it may come out at you. The flame might come right out at you. So you really got to be a little bit careful, a little cautious on there. And if it comes out back at you, you might have some issues on there. So, all right, so let's go ahead and get that back up. There we go. All right. Might come out at you, so you got to be a little bit cautious on there. If I continue to add on to that, I said if the flame is lazy and wavering, so I made mention about the flame's going to look for air. So I'm going to say if the flame is lazy and wavering, that's really what lazy means. A lazy flame is a wavering flame. It's a flame that is not super defined. Then the first thing I would do is, get your combustion analyzer out. Get that combustion analyzer out to see if your carbon monoxide, your CO, your carbon monoxide levels are out of line. This is actually kind of a tricky one. The obvious ones are pretty easy. If the flame is wavering all over the place, chances are you may not need a CO measurement to figure this out. But the reality of it is, if the flame, I've seen some of these flames where it didn't look terrible, but yet carbon monoxide levels are through the roof, and they were having intermittent issues with the rollout actually opening up. So it was one of those where you can be very much fooled. It's really difficult to see a flame that's building carbon monoxide. So that's kind of one of those things. You just have to be a little bit cautious on there. And I would say this, see if they're out of line. And I would say if I add on to that, only when, let's say the flame looks somewhat normal. So what I mean by that is, don't get an analyzer out. If you see it's lazy and it's just all over the map, don't bother getting, you don't have to get your analyzer out to test that. Just realize that it's probably going to be very high if it's doing that. But the ones where if you go on a job and you see the rollout is tripped and you reset it and you look at things and you see, well, it looks decent, get the analyzer out. That's definitely where you have to do that. Additionally, clean, what else do you do? Clean the heat exchanger. Now, depends on the unit. If this is a boiler, you're going to probably be cleaning the heat exchanger. So when I say clean the heat exchanger, I'm saying clean the heat exchanger when it's appropriate. So clean that heat exchanger when it's appropriate. If it doesn't need it, it doesn't need it. So that's the way I would do that. In a lot of cases, let's say a crack in the exchanger will actually cause some of these, or will cause will cause a high CO or cause a rollout to go, and it's all about pressurization, and I'll talk a little bit about that next here. So a crack in the heat exchanger also causes this to open, and it has to be a fairly, it takes the right conditions to make this occur. So the point that I'm going to make is it's most notable when the blower starts. That's the trick. When the blower starts and you see that now it starts to waver, now you know that that's what's going on in this application. So a unit that doesn't have that issue, for example, let's say if you got a blower, it turns on and there's no change whatsoever, then it may very well not be a problem with that. So you have to those are judgment calls that you kind of have to make, and these are not easy sometimes to find, just because of the lack of visibility of a heat exchanger on these systems. So that's kind of the one thing. So additionally, I'm gonna make another note on your to be cautious, to be very cautious. So and I'm going to use the example like on boilers, or furnaces that are boilers and furnaces that are lacking air. So for example, I say look at your combustion air sources. Confined space, unconfined space. Those are things that we look at at that. So on a sealed combustion furnace, you're not going to worry about that as much. But on a boiler where it's indeed open, that's a different story. So like on a drafted furnace, as an example, or any type of mid-efficiency appliance, I would definitely be looking closely at that to see what's going on with that. So sometimes you're going to look at everything and it tests out fine, and you could have a rollout that goes on there. You got to do something. You can't just change the limit and say, well, it was just a bad limit. You have to do your due diligence to check that over to make sure it's all good. Sometimes with combustion air spaces, I've even done this where I try adding additional, let's call it adjoining space, adjoining areas. And so in other words, this is a code thing. So if you were to look in your code book, the National Field Gas Code Book, you can kind of look at a space and say, well, geez, with all the BTUs that I'm applying, that I'm putting into this system, if that space is confined, or that space, you could have a situation where that building or that mechanical room is in a negative pressure. And if that's the case, these little oddball type trips and things like that could start to create some of those nuisance things on there. So, and again, this is, try adding, those, and I would say especially for non-direct vent appliances. So those are the kickers that you want to look. Any type of a non-direct vent system. Now, again, to reiterate this, what do we mean by a direct vent appliance? A direct vent appliance would be an appliance that gets all of its air from outside, and it basically burns what it needs to from that air and the fuel, and it sends it on outside. So it's not using any indoor air as part of its process to some extent. So that's kind of the typical way I would do that. All right. So let's take a look at the next. Let's take a look at the next area. All right. So there is specifically the next one I wanted to deal with was called an exhaust. Typically the exhaust limit. So an exhaust limit. Now, first of all, the exhaust limit is not, I would say, the most common of the limits that you will see. So in other words, this is the exhaust limit that. There we go, that exhaust limit. Now, typically the way that I've run into these is they will be located as soon as I get my, there we go. They'll be located in the exhaust blower of a lot of furnaces. So I know, and I've seen Tempstar use them, I've seen Trane, American Standard, a variety of manufacturers that have done this. And there's good reason for it. A lot of boiler manufacturers also put an exhaust limit in there. That's typical. Now, let's take a look at what it is. So a couple of notes that I'm going to make. So yeah, let's see, exhaust limits. Normally seen on condensing boilers. Typically you'll see it that. Some condensing furnaces you'll see some of them used. You got to look at its location, where it is, and where they're typically seen. Its intent is to limit the flue gas temp. Is really the idea. That is really the intent. It's to limit the flue gas temp so that you don't put too much heat in those vent pipes is primarily the reason for it. Now you might say, well, why would that be even needed? If you think about it, PVC limit is 140 degrees Fahrenheit. So that's the typical limit. So that's why you're worried about that as a rule. Whoops. There we go. So that's kind of the one thing. PVC is limited to 140 degrees. That means, you may say, well, why would that be of concern? PVC pipes tend to get soft, actually. They really tend to get soft, and they get soft and may actually burn over 140. So that's an easy way to create a problem for a customer on there. So that's primarily the main thing. So you might say, well, why, what do I need? What am I worried about? And obviously, on an exhaust limit is primarily, I've only seen them on condensing furnaces, condensing boilers, those types of things. And again, the whole thing is they don't want to soften, they don't want to create a problem, which would be really devastating for some of these applications. Wiring, the typical wiring in there, again, I'm just going to put a note in here, in series, with oftentimes with other limits, most of the time, and that's the kind of the standard, the norm. So now exhaust limits. Let's talk about, what do you do if one of these has tripped and what things are going related to that. So let's hit up on this one. So the first thing I would say on here is, to basically go ahead and, measure the exhaust, measure that exhaust temp, exhaust gas temp. That's what I would do. Measure that exhaust gas temperature, and obviously get, the fancy meter you're going to probably pull out is get the combustion tester out. That's what you want to do, combustion analyzer, and get that thing going. So that's kind of the one, combustion, run the combustion test, find out what the heck it is. You might want to look, if that's the case, here's the next thing I would tell you, pull that inducer off. Pull the inducer off, look for soot. Look for soot is what I would tell you. So you're going to look for soot in that secondary exchanger. So typically, what I would say that's probably more normal to some extent, if indeed, if this particular, let's say that this heat exchanger starts getting all sooted up internally, if that indeed happens, one thing that I'm going to tell you is that if that happens and that gets sooted up, what will happen is that heat exchanger will not extract the heat out of that. And you may end up getting, let's say, 300 degree, temperature of air of combustion products traveling through that secondary exchanger and not really extracting a lot of heat. So that's kind of the logic of the reason why they're doing it. So it's something on that order. So you're looking for whether it's an overfiring situation, which is unlikely, but that's kind of one of the things that you're looking for related to that. So that's kind of the one area to address that. All right. Let's take a look at the blocked vent limit switch. So a blocked vent limit switch. Now the blocked vent limit switch, I have a couple little drawings that I'd made up here. And the blocked vent limit switch is generally what you're going to see something. I'm just going to make a few notes here. It is the block vent limit, the intent of that block limit is to, it's generally going to be only on category 1 appliances. So category 1 appliances, that's generally what you're only going to see that on there. And that includes boilers and furnaces. So is what it is. So boilers and furnaces. So you're only going to see it on those two as a general rule. It would have to be a natural draft. So you're dealing with a natural draft system. Well, I'll just, natural draft, whoops. Apply. Natural draft appliances is one. I think the big thing, you're hoping that it can detect a blockage in the flue. It's almost self-explanatory by the name of it, but it isn't quite as simple as that. Block vent limit switch. So detecting a blockage in the flue. I should say flue, not flues, but in the flue. The one thing that I would tell you is that this is one of these where, yep, I'm expecting it, a blockage in the flue, but I'm also going to say that, also can, I would say it's also a problem for systems that don't want to draft. Not an easy fix for those systems, and it can be an issue. So if you can't get a system to draft correctly, it may show up and it may look like it's spilling, and so the obvious thing, that's kind of the one thing. But the obvious thing is you've got combustion gases that potentially are going to be, let's say they're flowing up. If the combustion gases are flowing up through that appliance and they're spilling out, they'll go right back into the room, depending on where that is. So that is their access into the room, is through the relief, the draft hood or the barometric relief opening, the draft hood opening, anything like that. So that's kind of what they're banking on. So you have to really watch that if you run into an issue on a job where that's happening. Wiring, The wiring on stuff like that typically is the same. You know, you're going to look for something in series. So this is one where I would generally just put a note on there is in series. It's going to be in series with, you know, with the ignition module / gas valve, and that's typical. So you just kind of, yeah, you kind of know that it is. Obviously, a block vent goes out, you got a problem. That's something you got to address. You got to deal with it. And it's sometimes the solution is extending it. You know, it might even be that. So, all right, let's talk about, you know, some of the troubleshooting on that. So, you know, what do you do if it's tripped? Well, if it's a blockage, you know, clear the blockage. I think to some extent, you know, the obvious things are do the obvious things. You know, clear the blockage if that's what it is. If there is a blockage. Now, I'm not saying every time it's going to trip because of the blockage, but I am saying this is, you know, check the venting. Check the venting, air for combustion. These are all things that could be an issue. That could make it very challenging for a technician. So not super easy. It's not the easiest one, but you know, you're going to want to look for that. You know what? Sometimes what'll happen is if there's a blockage in the chimney or the flue, or you've got a vent pipe that's collapsed or leaking or something like that, you know, it's something like that. I'm going to just put on there, you know, air for combustion. And I'm going to say on here, check the venting. That's what you got to do. You got to check the venting. You got to check the whole vent system, look it over, see what's going on in there. You know, you got to look at that. You've got to indeed look at that and make sure everything is good. So at that point, you know, if I've got a problem with a block vent limit switch, I'm really thinking venting. I'm thinking, you know, is there a problem with a vent damper not opening? You know, you could do that. You know, there's some of these, you could say there's some of these units have these vent dampers that are like thermally actuated, you know, especially thermally actuated. So I'll put a note on there, actuated. The other ones you wouldn't expect that, but you're clearly looking for a blockage of some sort or a lack of draft, something like that. So that's kind of the one thing that I would point out on here. You know, and I'm just going to put a note on there: fix the draft problem. That's a whole nother lesson. So that's primarily what that would be. All right. So in my two examples that I've kind of shown on here, again, I've showed a block vent limit. That's going to be essentially, it normally should be seeing dilution air, draft hood air, but in the event that, as my two pictures of my boiler show up above here, is the intent or the idea on that is that dilution air will kind of feather its way up through there on both sides. And if there's any problem, it's going to spill back out and it'll be hotter, which has to be, again, you have to address that. These are serious problems. All right. The last of the limits that I have on here is called the auxiliary limit switch. And the auxiliary limit switch is going to be something that you're going to see on multi-positional furnaces, downflow furnaces, rooftop units, and it's some of the manufacturers will call it what they might identify it as called a fan failure limit. Now, I left my note in here about this. I said it's especially important on multiple rooftop units. On a downflow, it's installed in the blower housing oftentimes or very near the blower housing where that high limit would not detect the issue. So for example, if I have a downflow furnace, and let's say that my high limit is at the bottom side of the heat exchanger, and let's say this fan breaks. So in this image, so I'm specifically talking about this unit here. And in that situation, If indeed this fan breaks or fails, doesn't function anymore, what will happen is the air, this limit here will actually detect the cooler air that will kind of make its way back up through here, is what it'll end up doing. Even though that it's supposed to be going downward, it's not going to go down. So that's one of the problems you run into is it will detect the colder air. That furnace will keep running and running and running. Your only chance to stop this furnace is the auxiliary limit that they're going to locate somewhere around that blower, at the outlet of your blower, somewhere in that area. So they kind of almost intentionally do that. On an upflow furnace, don't forget it, they're also going to be located in that upflow application is kind of how they're setting it up. So that's kind of one of those that just to be aware of, that is indeed will indeed happen. So in a let's take a look at the second part of this. I said fan failure limit, and it's a problem with rooftops. So I made a few notes on here and made up a little drawing here just showing kind of a basic rooftop system, just kind of showing you what's happening. So on the left side of the drawing, I'm showing a rooftop there, and it's showing the return air coming from that system going right up into there. On the right side of that left side picture, you'll notice the supply air that's skedaddling out of that supply duct and so on and so forth. Now, typical rooftops is they're going to have a blower assembly right there that would normally show that. They're going to have the heat exchanger that will be in that area. And what will indeed go on is on a unit that's operating correctly, you're going to have the economizer open, a minimum position as a general rule, and it's simply going to blow that air right into that space. All right, now, the left side, as in a lot of the larger spaces, the rooftops will oftentimes do this. Many of these rooftops you might have 2, 3 rooftops, 4 rooftops in a space, and they're doing it to kind of spread out the demand. Rather than to put one big giant unit, they'll put a bunch of smaller units in there. Now, if they open up, or they basically are bringing in enough air and the furnaces haven't satisfied themselves, and they might actually set it up where they might have one thermostat that might go to several units. They don't have to, but that could be a possibility. So in this case, if they have if they've got a furnace or a rooftop that's blowing that warm air in that space, that's kind of the one area. Again, we're talking minimum air for ventilation. All right, now, in the event that one of those units fails, let's say a belt breaks, and they don't have any way to detect that, what would happen is, if the building and we would expect it, is that if the building pressure gets sufficient enough, it will blow the air backwards through the open unit that still hasn't figured out that it's blown, or that the fan or the belt is broken. What will happen is the air will go backwards up through the supply air, that supply air will go back up through the unit, and it'll actually cool the high limit. And the high limit will not detect that failure. Then what will happen is the fan failure, which is located in the fan housing, will actually pick that failure up. And that's how they do that. So that's why they typically will see that. So that second unit, they'll put a fan failure limit at that outlet, or at the top of the heat exchanger, or the blower housing, or something like that, to pick this up. When you see that happen, that essentially is one possibility, and that's why every one of these rooftop units does this. And they do that intentionally because they know it's a realistic possibility. So that's called the fan failure limit, is the way that's set up. All right. The last part of this particular module I'm going to hit up on here is earlier I talked a little bit about some of the fan settings or the limit settings, but now I want to specifically talk about some of the fan settings. So I talked a little bit about some of the issues that we might have to deal with. So, all right. So first thing is the fan switch settings, they're really way more critical for comfort than they are safety. So these are settings that are applicable to safety, but they're really more about comfort. The object, or what I'm going to call is the objective of this, is to have the lowest fan on and off temperature settings that are not drafty to the customer. You don't want the customer to feel cold, and that indeed is a problem. So in symptoms or systems that have time fan on and off settings that have the same concerns as really they have the same concerns as temperature switch fan controls. They're no real different. So by going electronically, it doesn't fix that problem. That's just a characteristic that would have to be addressed with the design of the system. So earlier I talked a little bit about the fan settings. So the lower I make them, I get more efficiency. And I'm specifically talking about either turning the fan on sooner, leaving it on longer, or having temperatures that are lower. So that's kind of one of those. Your settings, they must be set up so you don't get the short cycling or nuisance tripping or nuisance operating of the fan. So when they talk about nuisance operation of the fan after shutdown or on hot days, we're talking about those situations where you shut the unit off, it's still got so much heat in the heat exchanger, now we got to go ahead and turn the unit back on because we're off on high limit. And so those are the things that are realistic. So let's talk some temps and times. So the fan on temp is in that 125-ish degree range. So I've seen numerous units and job sites where they would have it 125, 130-ish in that area, but 125 degrees is a fairly good temp to use. So remember, you're waiting for the heat exchanger to get warmed up, to warm up that air to about 125 degrees before you start that blower. Then once that fan turns on and the heat call is done, then you're going to shut it off somewhere when it gets around 20 to 30 above the room temp. So that could be, if you're maintaining your building at 70, that might be 90. If you're maintaining it at 70 or 75, it could be 100 degrees, something like that. It's about 20 to 30 above. So I would say 90 to 100 degree setting is very typical. And the last of the settings is the fan on time settings. Typical, I said on the fan time on is typically in that 45-second range. I've seen them 60. It manufacturer controls that. The off timing is completely dependent on the field techs. So the off timing, a starting point might be 60. But if you have a restricted airflow system, that could be up as high as 3 minutes, is up to 180 seconds. So that's one of those where you want to be very, very careful on that setup on there. So that's a little bit on those settings on there. All right, so that primarily concludes that section and that area. There's quite a bit that I've gone through on all these limits and fan controls specifically in that section too. So what you'll need to do is just make sure you review those up.